Today we're doing an unboxing, and this is courtesy of JEYI. So I want to thank JEYI for making this video possible. Whatever product that you've ordered, be sure you put a camera on it so when you open a package that you will receive what you've ordered. Now, I didn't realize this package had been ripped open, so I'm just now realizing that my sinuses had me out of whack. So when I got this, I just picked it up, set it in the house, and now here I am in the studio, and the sack is ripped, as you can see. Now, these four products should still be intact, but we're going to look at this and see what we have here together. Number 1, number 2, number 3, and number 4. So far, so good. And an order receipt indicating 4 items. Fantastic. Let's take a look at the labels and see if we can make out what this is. The largest box is a JEYI dual M.2 NVMe enclosure. Next one we have an M.2 Heatsink Finscold series, and this is the Goldfins 001, and this is also a JEYI M.2 NVMe enclosure. Next one, this is the JEYI NVMe Heatsink Finscold 007, and this is the one we're going to be opening. And of course, separate videos for all 4. Okay, so everything's intact. I'm thankful to know that. And boxes are still sealed. Nothing's been messed with, so we're dealing with factory seals. Now, what we're going to have, this is a dual pack. Let me show you how this product is listed. Now, this says this is the JEYI M.2 Heatsink Finscold 007 2-pack, and that's what we're going to be looking at. What I find fascinating is this has almost looks like the possible option of being an option on a brand new motherboard where it could replace the stock heat sinks. In other words, this looks like it's thin enough that it will clear the I/O cards, but the question is, will it be as effective? Now, we're going to also need to look at our chart. Been a while since I've looked at the chart, where we've tested 14 M.2 NVMe heat sinks and 3 thermal pads. So this will be number 15. Let's open it. One piece of tape to cut, and voila, there we are. We have 2 heat sinks, 2 screwdrivers, and a bunch of screws. Let's see, 1 screwdriver, 4 screws, plus an extra or optional, looks like set screw for the end. And we also have thermal pads, 2 and 2. I'm curious about the thickness of the thermal pads, and I'm also curious about the thermal conductivity rating. Those look like they're of equal thickness. So to get a quick reading, 0.8 and 0.8. And the same thing for the other package. And then there's their certificate they include and a barcode to scan, and it'll take you to instructions. Hopefully this is going to be meaningful and helpful to all of us. Now I'm gloved up. Let's get one of these out of the package. Well, these are tiny. The camera's on autofocus, so I'm going to hopefully be able to have something for it to focus on, and you'll be able to see this. But I just want to let you know what's going on. Most important part of this, there's 2 parts to this enclosure. We have the wraparound, we have the heat sink, and of course then we have the 2 thermal pads. And what I'm curious about are on the side, the holes are elongated, and based on where they're lined up, because they're elongated and where they line up at here on each end, we'll be able to get either single-sided or double-sided in here. And I think that's going to be important going forward. What I'm curious about is if there's going to be room on top for the I/O cards to be able to pass through. And that brings up an interesting question. Since there's 2 in the package, we normally test these, and we're working with the Gigabyte TRX40 Designare, and I'll show you the motherboard layout when we get to that. But what I want to do is get one of these mounted, and since we have 4 M.2 connectors on the motherboard, I'll take a look at the chart so we can look at that, compare, because it's going to take a little bit of time to go through the key on how all those lay out, so we have some kind of comparison. So to reiterate, we're going to set the drive that ran the hottest that we did most of the tests with, the WD Black SN850. We'll put that in, set it to the 2nd position on the motherboard, because that 2nd position on the motherboard, those first 2 connectors are to the CPU, and the second 2 are through the chipset. So to have apples and apples results, let's take a look at our baseline on our stats, see what we're working with. Okay, on the chart, the numbers we're going to focus on. Number 1, the WD Black SN850 came in at 92 degrees, and that's bare. Number 2, on the TRX40 Designare, the 2nd heat sink, that comes in at 65 degrees. And of the all-around total 4 connectors, as many had said, the MHQ JRH was pretty good for the price for the temps it received at 62. And that was better than the stock heat sink. Okay, our 2 very best, which were kind of large, was the Acidity 4-pipe here, number 9, came in at 48 degrees. And down here on number 22 was the JEYI Finscold iGlacier 8, That came in at 48 as well. So those are our two best performers, but in line with the size, the MHQ JRH, and I'll have a link up to these, came in at 62. And then the chart on the right, I'm not going to get into, but that was where we tested on 3 different quad cards. The Asus quad card, a Gigabyte quad card, and an ASRock quad card. And we tested with Sabrent drives as well as the WD Black and SN850 because we needed 4 drives to test with. Okay, now that we've looked at that chart, I want to take a look at the specification chart for the drive we're going to put on here because it's still mounted, and that's the way I keep these stored on the Supermicro dual M.2 NVMe adapter. Makes it easy to pull them off and test. And this setup is a test with the default using the default pads, the default setup for this heatsink, because I want to see how it compares with the results we've had for the stock, with the results we've had on the best of the best. Let's take a look at the WD. Okay, the data sheet that gives us the information we need down here on the bottom. We're looking at operating temperature 0 to 70, and it's PCI Express 4 lanes. This would be considered on the 1 terabyte version, which we're using, 7,000 megabytes on the read, and the 1 terabyte is 5,300 megabytes on the write. And yes, there are newer drives, but we're testing with apples and apples to keep this all the same, because we didn't expect to do any more testing with heat sinks until we got with PCI Express 5, considered all that's going on. And when JEYI asked us to take a look at this, I said, absolutely, be glad to. Because of the amount of information that we've got, which is a test, always we say test and verify. This is something you can do on your machine and see what kind of results you get. PCI Express 3 is not that big a deal with heat, but PCI Express 4 is a very big deal, and it becomes a bigger deal with PCI Express 5. So let's, now that we know the parameters we're working with, I want to go back to the chart and double check that. So to reiterate, on test number 2, the TRX40 Designare, the second heatsink was at 65. And on number 4, the MHQ JRH was at 62 degrees. And still the profile was too tall to have anything above it, but it was a lower profile for the cost that made it reasonable. And our very best was number 9, the Acidity 4 pipe at 48, and number 22, the JEYI Aluminum Finscold iGlacier 8, also at 48. So our goal, hopefully we will achieve somewhere between 65 and possibly 62. And the drive bare is 92 degrees. So what we'll do first, to reiterate, test this on the motherboard. We'll get the drive mounted in it. And then what I want to do is test both of the heat sinks on the Supermicro dual M.2 NVMe adapter, because that's where all the heatsink testing started when you guys asked, okay, this is a bare card, meaning no heatsink. So how do you, and the problem we ran into with so many of the heatsinks we tested was because due to the thickness and the proximity of one slot to another, we didn't have a lot of space to put a lot of stuff in there. This looks like that may solve that if it's something more like stock. So let's see what we've got. 2 pieces. That's machined. Of course, this is aluminum. And oh, it even has a couple of stops on the bottom. Turn that where you can see it. 2 holes there on the bottom. And then the tray has a notch out. So the way we're going to be looking at this will be like that. So that way we have our notches lined up. And then the bottom of this, when it sets in, has a stop so that it won't go any further. Interesting. So that's black anodized aluminum that's been machined or milled. And I'm curious about the design to see how well this is going to work, how it's going to function. Peel the bottom layer off. What's curious as I look at this and compare, seeing where the alignment is, on this right side where it has the metal tabs and the way it was in the package, that's going to be alignment for the screw hole. So the other end that's going to be opened in, which is on the left side, that'll be for the M.2 connector. Okay, makes good sense. I kind of like to do a dry assembly. Thermal pad will fit, and that will line up. And I'm comparing the one I took out of the package to the one that's still in the package. So as I roll this and we see the label, and the label right here, I just want to make sure I'm lined up the same. So I've cleared the thermal pad of the notch, and this is the same notch where the screw is going to sit and hold it down. So now let's take the WD Black SN850 1 terabyte, turn that around, and I know I've still got to pull the plastic off. I'm doing a dry assembly first. Yeah, that looks good. Okay, so now I'm ready to pull the protective coating sleeve off. Very gingerly peel that up. Perfect. Good positioning. Put the memory in place, drop it down, turn that around, line up our holes, and I'm double checking. Now we'll get our other thermal pad mounted on the top. And just a quick alignment. Yeah, I want to make sure we're good front to back. What I'm going to do, turn that around, and I'm going to line this up from the controller all the way down on the memory. Perfect. A lot of times the pads we've had from other vendors have been disproportionately long, or when we try to peel the protective surface off, they would stretch. I've never seen pads like this. This is a silicone type material, which we can appreciate, and that stretched a little bit, but we got good coverage. And now we'll put the top to it. Interesting. For aluminum, that's got some weight to it, and that looks good. And we can see where the screw holes are going to be. I'm kind of curious what kind of screwdriver they provided. If it's magnetic, we'll see. And I appreciate the screw they provided also as a hold down, because one of the things I didn't like about the Gigabyte TRX40 Designare is those double screws they put in there for the stock heat sinks. They're a nightmare. They weren't made to be tested with like we do. Installation and swapping parts out. It's magnetic. That I appreciate. Okay. Number 1, roll that over. Number 2, and I'm not tightening those down, I'm just getting them in there, and they provided 1 extra screw I see. Nice, just in case. Number 3, and now number 4. Okay, now what I'm going to do is hold that in one hand, thumb and index. I'll secure one side, roll it over, secure the other side, and come over here and put pressure on this end, secure one side, roll it over, and secure the other side. Nice. And the total assembly comes out to 11.3 millimeters. I was curious about that. And of course the next step then will be to get the area clear, get this on the motherboard and see what we test out at. Nice assembly. I've always been concerned about alignment. And everything looks good on this end, and that's where the stops are at. And on this end, everything looks good. We're clear of the notches on the connector. That's what I wanted to double check. So our next step will be to get this on the motherboard. And we've got to take that heatsink off first. I'm going for a close-up right there. And the top part of that is out, which is a 2-piece screw. Heatsink removed. That thermal pad's going to have to be replaced on that heatsink one day. It's been used quite a bit. And let's see how that's going to perform. Yeah, I want to take a look at it. No, there's quite a bit of difference. Still thicker than the stock heatsink, but we needed to double check. In other words, once this goes on the motherboard, I don't think we could put anything that would cover it, because I don't think it'll clear the slots. But I just make note of that, in case that's a concern or consideration. For us, it would be. Now, based on the double screw, the stud that is on there, we're at the level that should match up for that connector. And I'm going to see if I can do this gingerly, and looks like we have contact. Okay, that's about as close in as I can get it, as sharp as I can get it. We're good on the connection, and we're also good where the screw has to go in the front. Now the question is, which screw are we going to use? I'm going to try to use, but I don't think the threads are the same. Yes, they are. Well, that'll simplify life if I can use their screw to secure that drive, instead of having to use the one from Gigabyte. So let's see. Perfect. It fits. JEYI thought of everything. 4 screws to mount the enclosure, elongated holes, and they provided an extra set screw to secure the drive to the motherboard, as you can see right there where I'm pointing. I'm zoomed in about as tight as I can go, and I'm going to have to zoom out a little bit on that. Some perspective. Perfect fit. So far so good. Okay, I'm going to double check, make sure everything's ready to go. Always do an inventory. Everything's plugged in. And what we're going to do now is we're going to go to the BIOS and make sure we recognize the drive to make sure I got the connector in correctly. Because if I've done anything wrong, I need to go back. There's no way the operating system is going to see that drive if the motherboard BIOS doesn't see it. So we're going to go to the BIOS, take a look at it, we see it, save it, come back, go through what I just said. Turn it on, energize, power. Now what we're going to hear is the post, the power on self-test, because I like a PC speaker. I don't like looking at the post codes. I like to hear that report, that beep. Once we get the report, BIOS. Yeah, it's definitely sitting up above the slots. We couldn't have anything over it. But it's a neat addition, and I think it's going to work well on the Supermicro dual M.2 NVMe adapter. The question is, what kind of results we're going to get? We'll see. Post, in BIOS, advanced mode, system info, plug-in devices info, and down here M.2 slot info. Okay, we have the Seagate FireCuda 520, that's the boot drive, and there's the WD Black SN850, M.2M and M.2Q. To reiterate, both of those are to the CPU. And the other two down here, M.2P and M.2C, there's nothing plugged in those. Those two will be through the chipset. One other place we can look, under boot, and yeah, there's a Seagate FireCuda 520, and then there's our WD Black SN850. So all we have to do is F10, save configuration, exit, system reboots. Now we'll go into Windows, and we're going to put up a couple of screens so we can do our heat and speed test, and that way we can, for that one drive, find out how that one heatsink works. First test. Post. And I'll also reference the spec sheet again on what kind of temperature we're looking at so we can go back and forth. Okay, now that we're up in Windows, we need to verify several things we need to go through. First of all, we're going to verify the drive exists. For that, Windows flag E, this PC, and there it is, the WD Black SN850. That's what we want to know. Now the next step, what we want to do is verify, because every one of these drives has its own control panel. So we want to verify we're running the current version of the control panel for this, which is the WD Black, actually it's the Western Digital dashboard. And once we've got the dashboard current version running, then we're going to take a look at and interrogate the drive and see if there's a new firmware. If there's a new firmware, then we're going to apply it. We got to do all that before we run our test to make sure everything's current, because the firmware on these drives can absolutely affect performance. And the drive that we saw the most performance affected on was the WD Black SN850. So I hope that heads up will help you to understand what we're doing. So right here we'll call up dashboard, and I expect there's going to be a new version of that. Okay, right here it says at the top, new application available. So we'll get the new application. Update now, all part of the process. And as before, it will load and immediately see the drive, and that statement now is clear. And curiously, oddly enough, up here at the top, I expected there to be another firmware, and there's not. Shows the model, shows the firmware version, and drive health and security frozen, so everything there looks good. I expected a new version of firmware, but to reiterate, not one. Very surprising. And just to go over some stats real quick, shows our current temperature 46 degrees Celsius with a maximum and a minimum, and shows our interface, or PCI Express 4 lanes, capability and connections. And based on the specs of the drive, to reiterate, 1 terabyte, 7,000 megabytes. The write on the 1 terabyte is 5,300 megabytes. And the temperature we want to stay below, that 70. And based on our spec sheet, our goal is to do better than number 2, which was the TRX40 Designare second position heatsink, which is where we're at, 65 degrees. And also to verify, that's position number 2. Position 1 is underneath the GeForce RTX 3080 video adapter. And then this long heatsink right here, here's where the other two are that are to the chipset. So we're focused on this position here. And our goal is to see how well this is going to perform. So let's do the test. First thing we'll do is call up hardware info. And we're going to have this in sensors only. That's all we need. We'll keep that on the left. We need to scroll to the drive. And we're looking for the smart drive technology. As you can see here on top, the Seagate FireCuda 520. And here's the WD Black SN850. So we're going to look at the minimum, maximum, and average. And that says we're coming in at 48 degrees. Let's call up Crystal Disk Mark. And the version we are running, Crystal Disk Mark 804X64. Now we're going from the C drive to the D drive. 1 terabyte drive, so we'll do a 1 gigabyte test file. And we're going to do the default test, all. And we'll highlight. Excellent results on the read. Good number on the write, so far so good. Drive temperature we're holding at 55 degrees. I'm impressed. I'm really impressed. And the test is complete. To reiterate, on the read, 7,069 megabytes, and on the write, 5,392 megabytes. I like both those numbers. But the heat is amazed because I'm flabbergasted. We held at 55 degrees. Every time we do one of these, my expectations always go out the window because things never turn out the way I expect. I didn't expect this to be this good. I'm really, really surprised. And for those that want to know the temps, let me show you that. Our ambient temperature, the room temperature, started out at 30 degrees Celsius, and it's risen up to 31 degrees, which puts it at about 86 degrees, I think, Fahrenheit. But I thought I'd keep it all the same, apples and apples. So the drive is coming in. Now it says 57. So when the test completed, we were still at 55. 57 I can still live with. And the ambient temperature has risen a bit. We're at 31 degrees. And how does that compare on the chart? The stock heat sink was at 65, right here number 2, and we finished up at 55. Now granted, it's not like the Acetylene, and granted it's not like the JEYI aluminum Finscold iGlacier 8, where those two came in at 48 degrees. But the closest to that, even the MHQ JRH, which I was talking about a while ago, came in at 62. As far as who has the best heat sink bang for the buck, JEYI has done some interesting engineering on this product. It works, and it works very well. Now the thermal conductivity rating on those pads, that's a new pad that I've never seen like. It's not like the regular gel material. It's a darker color. Feels like it has a little bit heavier mix to it. But the only way to increase that number or make it less heat would be to use a different thermal pad. What we're after is the stock to see if there's anything worth exhibiting or going any further with. Man, I tell you, that's wonderful. So we've tried one. Now we can try 2 on the Supermicro card. I'm curious what that's going to look like. Yeah, we need to do that. Well, those are incredible results. So in this next test should go a little bit quicker, but we're going to need to go through the same process and double check on the Samsung drive, the firmware, as well as the application to update the firmware, their control panel, which I believe is a Samsung Magician. So we'll check that, then we'll check the firmware, make sure it's all good, go through that process. Stand by. Now for the same thing on the Supermicro dual M.2 NVMe adapter. 1 is ready. We just have to make way for number 2. When you think about that, you've got 2 heat sinks here. This makes an incredible value for the package. This is smart, and I'm really impressed with the results. I always say, I know enough to know I need to know more, and the more I learn, the more I realize how little I know. Okay, same process. This is a single-sided drive, but the Samsung 980 Pro, yes, we'll leave the labels on, and these are different thicknesses through here, but we get pretty good compression with the drive. I'll come in on this a little bit closer and show you. I've never really shown the back of the Samsung. Even though it's single-sided, you'll notice it's got a copper plate on the back side away from the connector, and that's to help with cooling. But you'll notice the differences in the thickness from the left side to the right side. That's going to drop right in there perfect. Okay, we've already peeled the top surface off. That'll drop right in, right up against the stop. And these are made for 2280. Perfect fit. JEYI has really done their homework putting this package together. I'm impressed. Everything clears on the left through the screw hole, and everything on the right, as we look at the back side, everything clears through the M.2 connector. I always like to double check. So we have the 4 screws required, plus 1, and then we have the additional screw that if we were to use it like on the motherboard, we could use it in place of the stud that's provided by the motherboard manufacturer. I appreciate that. Now, since this goes on the Supermicro dual M.2 NVMe adapter, hopefully our nylon inserts will work with these heat sinks. They should. Now, for those that ask, what about double-sided memory? Something like the Sabrent, those are double-sided. But the WD Black SN850 and the Samsung 980 Pro are single-sided. Just getting the screws started. 1 and 2. Turn the assembly around. Number 3 and number 4. On the add-in card, in the top position, will be the WD Black SN850 and then Samsung 980 Pro in the second position. So I'll turn that over and spin it around, and that should just clear. And it does. Nice. So we'll take the second one, roll it over, insert the connector. Very nice. And push pin is down. Okay, and I always like to take a look at, this time, looking at spacing side to side. Those just fit. I mean just fit. The screws are touching each other, but they're fine. Interesting. And I always like to look through the thickness. Components all clear with the wraparound, so we're good for spacing all the way around. Fantastic. So our next step is to get this in the machine. I like the way that sets up on that card. We finally found, I think, the ideal cooler, package of 2, and JEYI has it for the Supermicro dual M.2 NVMe adapter. Okay, now this is going to be interesting. We're going to install this, then we're going to need to go into the BIOS, first thing we have to do is double check, because I don't remember the configuration for the slot. Now, to reiterate, this is the Gigabyte TRX40 Designare. We have two 16-lane slots and two 8-lane slots. Electrically, that's the way they work. Mechanically, they're all 16-lane slots. So the slot we're going to go into, since our GPU is in a first 16-lane slot, we can't get to the first 8-lane slot where I would normally put this, because we only need 8 lanes, and we need to bifurcate the slot. And that's going to be the requirement for one of these cards. You've got to have bifurcation 4x4. So I'm going to put this in a 16-lane slot for the testing purposes, because I don't have the quad card in here right now. We've got some other stuff we're going to be testing. So we're going to go in and set that by 16 slot to full bifurcation, as if there was a quad card, because each M.2 drive, of which there would be 4x4 is 16. We're only going to be using 8 lanes. If I were to use the other 8-lane slot, I either have two options I have to look at. I either have to change out the GPU. Let me show you. To reiterate, we either have to change out the GPU because of the width, since we can't get to that slot, or we'd have to remove the Thunderbolt card. It's in an 8-lane slot. So in other words, 16-lane slot, 16-lane slot, right there's an 8-lane slot and an 8-lane slot. And that's only using 4 lanes. But this is for testing purposes. So again, to reiterate, we're putting this in a 16-lane slot, but we're only going to be using 8 lanes, 4 lanes for each one of the 2 drives. We get so many questions about quad cards and dual adapters, and I have to look at motherboards, and I tell you, sometimes my eyes just kind of go like that, because I have to go through that process of slots and storage for PCI Express resource allocations on every motherboard. And that's what we've been doing a lot of. And yes, we got lots more still to do. Now, because of the width of the RTX 3080, this was for testing for some of the things we were doing, but I would have to put like an RTX, anything 2 slots wide. Like an RTX 2080 Ti would fit, it would be 2 slots wide, so I could get that 8-lane slot. And that's normally where I would put this. But for this setup, for this test, this is how we're going to do this. And we have the I/O slot bracket secured, so that's set. So doing a quick inventory, we're ready now to power up, go into the BIOS, and check that slot. Can't be set in auto mode, we've got to set bifurcation. Everything's ready to go. Turn on power supply, energize. Now as the system's powering up, we'll hear post. Once we hear the power on self-test report, BIOS. Okay, we're in advanced mode. We'll go to system info, plug in devices info, and it shows slot info. PCI Express by 16_2, PCI Express by 4 at 40x4. So let's verify the slot. We'll go to settings, I/O ports, and we have the primary slot is set for auto, and we just happen to have bifurcation set on that second 16-lane slot. That's what I wanted to double check. 4x4 by 4x4. So let's go back, system info, plug in device info, and the slot info is correct. So let's look at boot, and there's the WD Black SN850, and there's the Samsung 980 Pro. Okay, all we need to do now, or to reiterate, we've double checked, everything we've done is right, everything is still set. I didn't remember the status for the last time I've been there, because the last time I had been there had been quite a while. I have to go through all this stuff because it's really easy to miss a step, but everything so far is correct for what we needed. Okay, all we got to do now is save the BIOS, reboot, go to Windows, do our test. F10, yes, save configuration, reboot, and once we reboot, to the operating system we go. So we'll hear the post again, and this time we have 2 drives. I wanted to take you back and show you this right quick while we're waiting for the boot, so you can see how much clearance we have. That's really nice the way that sits up there. There goes the post. That keeps the configuration of the Supermicro dual M.2 NVMe adapter with these JEYI Finscold 007 or pack of 2 heat sinks. To reiterate, keeps this 1 slot wide, which is really handy. That's nice. It doesn't bleed over into the other space. Plenty of clearance here for air. And yes, the case is open, so ventilation flows through. And we'll check again our ambient temperature when we do the test. Okay, Samsung Magician is telling us there's a new version available, and a firmware update is also available. Okay, looking at the application, down there on the bottom left it says update. So we'll click on update, and that will take us to this screen. 2 things we'll see: Samsung Magician software update, and then a firmware update. So we'll do the software update first. Now while that's updating, you want to think about whenever you update firmware, especially on a drive like this, is you want to go through the process, power the system down, drain all the power out. So then when you come back up, the firmware will have been applied, and then you should be able to do your testing. Otherwise, your performance may be off if you run the firmware and don't go through the reboot process. Some control panels will do that automatically, but not all. And I don't remember what this one does. Install the update. Nice automatic procedure. Samsung Magician is already installed. Do you want to overwrite the previous installation? Yes. Thank you for asking. Welcome to Setup. Next. Good old EULA. Next. Accept EULA. Again. Next. Create the desktop and the quick launch icon. Absolutely. Next. Install. Install complete. Launch Samsung Magician. Finish. Yes. Interrogates. Automatically finds the drive. Tells us over here on the right a firmware update is available. So let's click on update down here on the bottom left again. And that will take us to the screen. Interesting, there's another update. Okay, we'll update the software again. That's new. We've never had to step through 2 updates consecutively like that before. Okay, already installed. Do you want to overwrite the previous install? Absolutely. We're in this for the long haul. And this will install the latest version, which will be 7.11. Next. Yes again to both EULAs. And yes to the desktop icon and the quick launch icon again. Next. Install. And no, we did not reboot between the installs of the application, but we will, to reiterate, reboot after installing the firmware. Launch Magician? Absolutely. We get the same comment again over here on the right. That's curious. So I'm going to close that one out. And over here on the bottom left, we'll click on Update. And what do we have this time? Wow, a third one. Third time's a charm. Okay, this is new. This is like doing BIOS updates almost. Samsung Magician's already installed. Do you want to overwrite the previous? Yes. This will install Samsung Magician version 7.20. All right. Next, EULA. And again, create the desktop icon and the quick launch icon. Next. Install and launch Magician again. Finish. And this time, better. Down on the bottom right, update your firmware to the latest. That's progress. Close that box. And down here on the bottom left, update. Let's see what we get this time. You are currently running the latest version of Magician. Well, hallelujah. Firmware update. Current version for the Samsung 980 Pro. We're going to say yes. Update. Update. Check system compatibility for the optimal SSD performance. Okay. And your computer will be shut down after updating the firmware. Perfect. In 20 seconds. Please save all your work before updating the firmware. Do you want to continue? Yes. Firmware update is in progress, and it will automatically reboot for us. Latest firmware download completed. The system will shut down in 17 seconds. And we'll say shut down now. And while that's updating, the system will shut down, recycle, come back up, and we'll be good to go. System's off, so we're going to turn it off, drain power. Let me show you the lights when we do this. You see the lights coming on? We hear the post from the PC speaker. Once we get that, we don't need to check anything in the BIOS. We'll go right into Windows and double check the drive just to make sure. There could be another firmware update. I want to make sure. Heard the post. A lot of work just to test a heatsink, but we want to make sure we get accurate results. So these things are important. And I hope this specificity will help you trying to decide which one of these heatsinks you want to try. I really like this one today. I did not expect to get these kind of results, but it's worth it. And this time there's nothing on screen yet about Samsung Magician, but I will call it up anyway, and we'll see what it tells us. Samsung Magician, yes. We'll click on Update, and fantastic. Running the current version of Samsung Magician software and currently running the latest firmware revision as well. Perfect. So that's all good. Now we're going to run our test. Heat and speed. We'll bring up hardware info. Sensors only. We'll be reading the smart technology. Let's scroll down and find our drives. There's the Seagate Firecuda 520, the WD Black SN850, and there's the Samsung 980 Pro. And the Samsung 980 Pro is going to give us 2 temperatures, which is really nice. One for the memory and one for the controller. But what we'll start our test with will be the WD Black SN850. So crystal disk mark, and we should have labels on the drives. We see D and F. Let's double check and see what D is. Windows flag E this PC, and just to verify and confirm, we have labels on those from other previous installations. So the WD Black SN850 is D, the Samsung 980 Pro is F. Perfect. So we're going to start with D. D drive, 1 terabyte drive, 1 gigabyte test file, all. And we'll highlight hardware info, and we'll watch our temps, starting out at 45 degrees for the minimum, maximum, and average. And that test is complete. On the read, 7,067 megabytes, and on the write, 5,396 megabytes. And of course, we're on the Supermicro dual M.2 NVMe adapter. And our temperature reading, that's curious, we came in at 54 degrees. Really interesting. And our temperature is up just a tad bit. We're now at 32 degrees Celsius. Those are good numbers. Let's look at the chart again. We're coming in at, now it's topped out at 55, but when the test finished, it was 54. So we're coming in at, the ambient temperature is up a degree, and this has gone down a degree. So even with the case full open like it is, those are some good temps. Let's look at the chart. Our goal was to be better than what we had, and we did. So number 2, the TRX40 Designare in the second heatsink position was 65, and we talked about the M.2 JRH at 62, which was a good number. And of course the Acidity 4-pipe number 9 at 48, and the JEYI aluminum Finscold Glacier 8 at 48. Considering the size of this heatsink, I'm impressed with the results. Okay, now for the third test, we're going to check the second drive on there. Let's see where we go. And this time we'll be looking at Smart on the 980 Pro, temp number 1 drive temp, temp number 2 for the ASIC, which would be the chipset. So be curious to see what kind of temperature we come up with. Okay, over here on the right, drive F, 1 terabyte drive, 1 gigabyte test file, all, highlight. And we'll see our minimum, maximum, and average temperature. And the test is complete. As you can see, the WD Black SN850 is just a tad bit faster than the Samsung 980 Pro. 6,906 megabytes on the read, 4,999 megabytes on the write. And our temperature on the Samsung 980 Pro, 55 degrees on the memory and 59 degrees on the chipset. So those are still excellent numbers. Let's take a look at the chart. Looking at position number 2 on the TRX40 Designare, second heatsink at 65. And of course, we want to stay under 70 according to the specs. Looking at the specifications for the Samsung 980 Pro, read speed up to 7,000, sequential write up to 5,100. And right here we want to see our operating temperature, 70 degrees. So we're well within spec. So I'm very pleased that this came in better than the M.2 JRH at 62, but that was on the WD Black SN850. This is on the Samsung 980 Pro. Very good, very good. So this product from JEYI, for the price, I would say is hard to beat. So, test 1 on the motherboard, test number 2 and 3 on the Supermicro dual M.2 NVMe adapter, and the Gigabyte TRX40 Designare motherboard. So, I want to thank you guys for watching. Welcome. This is BuildOrBuy. My name is Gil Boyd. I love my subscribers. I look forward to seeing you next video. We're out.